A matrix is an ordered rectangular array of numbers. A matrix with m rows and n columns has the size we call the dimension n by n. The entry in the ith row and the j column denote aij. So for example, if you look at that matrix right there, the given matrix, can someone tell me what the entry for A32? 9, right? Always row first in that column, right? So 9. A matrix is called a square matrix if number of rows equal to number of columns. Square matrix is really useful. If you don't have a square matrix, it's most of the time it's probably useless, right? Because due to the inverse probability. So this one is 3 by 3. Yes, it is square matrix. So far, so good. Let's just review. A matrix of a size 1 by n, meaning you have 1 row and n column, look like this. Just make up some stuff. So you have 1 row, 4 columns, right? So this is 1 by 4. Let me use black 1 by 4. We call that row matrix. If the matrix have a size m by 1, mean you have many rows but only 1 column, for example. Then this will be what? 4 by 1. Many rows, only 1 column. By the way, in a linear algebra, they call the two things as vectors. Right? A transpose matrix. If I give you a matrix A, say 3, 2, 1, -5, 10, 0, like that. So that's A. That's matrix A. If I want to compute A transpose, denote A to capital T. T stands for transpose. All you do is the first column turn into the first row. Second column turn into a second row. That's all. So 3, 2, 1 is gonna lie horizontally like that. And then -5, 10, 0. Does that make sense? It's pretty, that's it. Rows become column, column become rows. That's all. So if I have 3 by 2 matrix to start with, then I should end up with 2 by 3, right? Rows and columns swap. In short, A is m by n. Then transpose of A is n by m. Equality of matrices. Two matrices are equal if they have the same size. The two things here, they have the same size, and their corresponding entries are equal. So two things they have to satisfy same size and equal corresponding entry. For example, example number 1, are the two matrices the same, the left one and the right one? First of all, are they the same size? Yes, right. What is the size? Yeah, 2 by 3, 2 by 3. So yeah, they're the same size. All their entries are the same. Corresponding entry are the same. Yes, right. 2 is the same thing, 1 plus 1. 3 is 3. 0 is the same thing as 4 minus 4, right? 5 is 5. 7 is the same thing as 3 plus 4. 9 is 9. So yes. Yeah, they're the same size. First, you check if they're the same size, and you check for each entry. And they actually the same, right? Yeah. I know they've written differently, but they're actually the same. What about number 2? Because yeah, different size, right? This is 2 by 3. This is 3 by 2. So just say no right away. You don't have to compare the entries. This chapter is really easy, extremely easy. It's like elementary student can do this. Solve for x, y, z, and u in given matrix equation. Assume that these two are equal. Can you find x, y, z, and u using equality of matrix definition? Yes, right? So you can say 2x equal 3, right? What else? 3 is equal to the u, right? Y minus 2 equal to 5. And 2z equal to 4. Two x minus 1 equal 3. I have 3 equal u. I have y minus 2 equal 5. And 2z equal 4. Then you can solve them. X equal 2, right? 4 divided by 2 is 2. U equal 3. Y equal 7. And then z equal 2. Done. You have something like that on the exam, don't mess it up. Those are easy points. U equal 3. Yeah. Any question up to this point? So that's comparing two matrices. If they're equal, you can do that, right? You can set each of the entry equal to each other and then solve out the variable. Adding and subtracting matrix. If two matrices are the same size, you can add and subtract matrix. Now, if two matrices are the same size, it doesn't mean you can multiply two matrices. And I'll tell you why later. But for now, if the matrices are the same size, you can add or subtract them. And how do I do this? The sum of matrix A add to matrix B, obtained by adding corresponding entry into two matrices. Right? Same thing for the difference of A and B. So this one equal to what? 2 minus -3. I'm sorry, this is plus. Sorry, this is plus. So 2 plus -3, right? And then 3 plus 0, 5 plus 8, and 4 plus -4. That will be -1, 3, 13, 0. You can use your calculator, and you can use your calculator to do this. All you have to do is what? Compute matrix. We call this matrix A, compute this matrix B, and you add them together. But I don't know why you don't use calculator. It's not too bad. Do by hand. It's faster. You guys try 2. I'll give you a minute to try 2. Someone tell me what's your result. Yeah, left to right, horizontally first. -5, -3. Yeah. Good. Very good. Thank you, Mike. All right. So we just adding two matrices. Now let's talk about laws of addition for matrix. A plus B is the same thing as matrix B plus matrix A, and we call this commutative. Commutative. Oh. It's kind of like 3 plus 2 is definitely 2 plus 3, right? The reason being because each of the entries are real number, right? Remember, what is the rule of real number? A plus B equal B plus A, right? So at the whole, matrix A plus matrix B is equal to matrix B plus matrix A. Another rule, they call that associative rule. If I have a sum of matrix A and B, add to another matrix C, it is equal to matrix A add to the sum of B and C. This is called associative. Commutative. By the way, A minus B is not equal to B minus A, right? That's obvious. Even in real number, 3 minus 2 is not equal to 2 minus 3, right? So it should not be applied to matrix either. Show that A plus B equal B plus A. Let's do A plus B. 2 plus -1 is 1. 1 plus 2 is 3. 3 plus 3 is 6. -2 plus 0 is -2. 1 plus 2 is 3. 0 plus 4 is 4. And is equal to B plus A, right? You can try the other way around. -1 plus 2 is 1. 2 plus 1 is 3, etc. Number 2, show that A plus B plus C equal to A plus B plus C. Let's do one at a time. Let's do this one first. That one. A plus B. We did A plus B up there, so just copy it down. 1, 6, 3. Let me make this bigger. 1, 6, 3, 3, -2, 4. Plus matrix C. C is 1, 1, 1, 2, 3, 0, -1. 1, 1, 2, 3, 0, -1. Let's add them together. 1 plus 1 is 2. 3 plus 1 is 4. 6 plus 2 is 8. -2 plus 3, 1. 3 plus 0, 3. 4 plus -1 is 3. Let's do matrix A. A is 2, 1, 3, -2, 1, 0. Plus B The sum of B plus C. B plus C, well, your eyeball you can do on your head. B plus C, -1 plus 1, 0. 2 plus 1, 3. 3 plus 2, 5. 0 plus 3, 3. 2 plus 0, 2. 4 plus -1, 3. Are they equal? 2 plus 0 is 2. 1 plus 3, 4. 3 plus 5, 8. -2 plus 3, 1. 1 plus 2 is 3. 0 plus 3 is 3. Are they equal? So far, so good. This slide is really easy. All right, so that's adding, subtracting two matrices. As long as it's the same side, you're allowed to do that. Scalar multiplication. What is a scalar? You heard it all the time. You heard it before. Scalar is just a real number, right? Any real number. If A is a matrix and C is a real number, then the scalar product C times A is a matrix obtained by multiplying each entries of A by C. So for example, given A is this, I want to find what is 3 times A. All you have to do is multiply every entry by 3. That's all. So 3A is, I'll do like this first. 3 times the matrix A, which is 4, 3, -1, 2, 4, 0. And then you distribute the 3 into each of those entries. 12, 9, -3, 6, 12, 0. That's all. Number 2 is more something you have on the exam. Given A is that, B is that, find the matrix X, satisfy matrix equation 2 times X plus B equal 3A. So let me write down the equation 2X plus B, capital X. So 2X plus B equal 3A. Two X equal 3A minus B. So far so good. Just subtracting B both sides. Let's just stop it right there for now. Right. Well, let's take care of one thing at a time. Let's compute 3A minus B. 3A is 3 times 3, 4, -1, 2. Minus matrix B is 3, 2, -1, 2. I'm allowed to continue my calculation because the sides are same. 9, 12, -3, 6. Subtract 3, 2, -1, 2. 9 minus 3 is 6. 12 minus 2 is 10. -3 minus -1, so that's -3 plus 1, 2. 6 minus 2 is 4. And that's what That is 2x, right? 2 times x. Any suggestion? Any suggestion? I need x, not 2x. Yeah. We don't have division. We don't have rule for dividing the matrix by a number. But what do we have? Scalar products, right? So instead of dividing by 2, it's the same thing as saying what? Multiply both sides by one half. Yeah, so say 4 divided by 2 is same thing as 4 times 1 half, right? Right, so multiply both sides by 1 half. Let's cancel. Don't write this down here. We don't have a rule that allows you to do this. Say I ignore that 1 half, say divide both sides by 2 like that. There's no, it just looks weird, isn't it? The top is a matrix, the bottom is a real number. There's no way you can squeeze the 2 into a matrix or vice versa. So we multiply both sides by scalar. So now x equal, 6 times a half is 3, 5, -1, 2. On the exam, I do not want to see divided by 2. Okay, even though your answer is right, you meant that, but presentation wrong, I still take a point off. Okay? It's kind of like this. I have people do this. Some of your work is like this. It's the right answer, it's just the wrong way of doing it. That's all, right? That's what I meant by wrong presentation, but somehow you come with the right answer. All right, last one, and we'll do the quiz. Application example. Test score. Suppose there are 5 students in the class. Suppose the score of these students on 3 tests are as follows. Student A, student B, C, D, E. Right, matrix A to represent the information. That's easy, right? So I have to do right matrix A. 80, 84, 94, 82, 84, 86, 76, 74, 82, 88, 84, 76, 94, 96, 86. Where the first one say that's my A11, right? A12, etc. Your position, your location of each entry. So that's part A, that's easy. Now part B, what is 1/3 times A11 plus A12 plus A13? Well, A11, A12, A13 is these guys. All you have to do is add them up divided by 3, right? What does that mean? When I do 1/3 divided by those 3 points, I'm sorry, when I take 1/3 times of those 3 points, what am I doing in this context? I'm taking average of what? What does that mean in this context, in this problem? Everybody can do this, but you gotta know what you're doing, not a machine. What does this quantity represent? Average of what? Of which student? Student A, right? A. The average exam score of student A. What about part B? 1/5 times A12. A12, first row, second column. A22 right here. A2, A32, A42, A52. So 1/5 plus 84 plus 84 plus 74 plus 90 plus 84 again plus 96. Let me give you a happy ending, 84.4. And this is the average, what? Test 2. Yeah, test 2. All right, so that's easy. Right, so this, like I said, this slide is really easy. Quiz. I need some people to come up here. They're too thick in the back. So some of you need to come up in the front. No, you never have to write anything like that.